Well, good evening, everybody. We're back in the saddle here, and boy, do we have our hands full tonight. We're going to have a monster topic, and we're going to talk about modeling with some quadratic functions. And this is going to answer one of those age-old questions that we seem to ask ourselves every day when we're sitting in math. When am I ever going to use this? How is this helpful? Type of thing. And that's a great question. I think it's a question we should always be asking ourselves, no matter what class we're sitting in. And typically, I always use the argument that we're practicing our problem-solving skills, that portion of our brain that carries over into, multiple problems and as we look for that solution. But I think today's problems are going to give you a real good illustration of how math can be used in the real world as you start to put yourselves in the shoes of an engineer and start to think from their perspective, perhaps. So let's jump in here. A couple of things. We don't have a ton of writing here tonight, but this is get out a few of our definitions. And I want you to know that quadratic functions can be used to model a wide variety of real-world applications. Okay, real-world applications there. In this lesson, we'll focus on using quadratic models to predict and optimize. Predict and optimize. Again, we're thinking like an engineer tonight. Predict and optimize. Okay? And almost always, our solutions will depend on either the intercepts, okay? Could be the x-intercepts, could be the y-intercepts, just wherever the graph crosses the axes, or the turning point of the quadratic model. And we clarified earlier in class that a turning point is a fancy word for vertex, so I'll throw that in here as well. So it's really, if you can find the intercepts and you can find the vertex, you're going to be able to answer all of these questions tonight, and that's what we're going to analyze. Okay, first things first, we're going to use a ton of calculator tonight. So wherever your calculator happens to be hiding, I want you to make sure you grab it. Even if it's sitting out in your car or if it's downstairs, wherever it might be, pull that calculator out right now, and we're going to really use a ton of it. I'm going to introduce you to some new buttons. I want to talk about some buttons we need to be familiar with. I want you to hit the second button here, which is right here, okay? And then I want you to hit the trace button. So we're actually going to the calc menu. By the time we hit second trace, we're going to the calc menu, and you should be staring at this screen right here. And the two things that we're really going to use a lot of tonight are the 0 button, and we're also going to use the minimum and maximum buttons as well, depending on whether the parabola opens up or down. The 0 button is just a fancy word for x-intercept. In other words, when does the curve or the parabola have a height of 0? That's another way of saying the x-intercept. So with regards to our graph right here, let's say I have a parabola that does a little something like this. All right, I would use the 0 button to go find this point right here, that x-intercept, and I would also use it to go find that point right there. Okay, and then I would use the maximum button to go find this point right here. And like I said, if you can find the intercepts and the turning point, you're going to be in great shape tonight. Alright, the other really tricky thing on the calculator sometimes, especially right now for us, is finding a good window. Finding a good window is kind of like an art. It's not exactly an exact science. It's kind of a finesse thing, so to speak. But what I want you to do is if you go, traditionally when we hit the zoom button, I like choice number 6 the best normally. That takes me to what's called zoom standard. And as soon as I hit zoom standard, what it does is it by default sets my x minimum to -10 and my x max to +10. The scale is what we count by. That means that each hash mark is 1 unit in length. The y min is -10, the y max is +10, and again the y scale is 1 again, just counting by ones. And that's what we call our standard window. However, as much as I love that window and it's a great starting point, sometimes we don't see the picture we really want to see. So what I'm going to have you do right now is I'm going to have you go to y equals, and we need a negative in front of that 6 right there. So we're going to type in y equals negative, not a minus. Make sure it's a negative 6x squared. Believe it or not, your calculator has two separate buttons, one that's a minus, one that's a negative. Plus 42x plus 4. And if I do zoom standard, and again, if I'm going too fast, great time to hit the pause button to make sure you have that equation typed in. As soon as I hit zoom standard, it takes me to this window right here where my mins are 10s and my maxes are, or my mins are -10 and my max is +10. And what you'll notice is we do start to see the parabola kind of faintly through here, and then it comes back down here, but that's not really the picture I want. You know, probably the parabola goes way up above and turns around, and I want to be able to see the entire parabola. So the first thing I did was I hit my window button, which is the button right here. I hit that window button, and I went back and I changed my Y max to 30, I believe. And I thought, man, that's pretty high. That ought to give me enough room to see the whole graph. Well, as soon as I changed it to 30, I got this picture right here, which isn't nearly tall enough. It's slightly better, but still, it's not tall enough. So, like I said, it's not an exact science. It's more of a finesse. It's more of a trial and error as we try to get a good window. And so I went back and checked this out. I got real aggressive, and I changed my Y max to 100, and that's what I want you guys to do right now. Go back and change your Y max to 100. I haven't touched any of the others. I haven't changed my X min, my max, my Y min. I just changed my Y max right there. And when I did that, I got a really nice picture right here. I could see the entire parabola all in action there. Oh, the other thing I did change is my Y scale. I did tell the Y axis to count by tens. And then I got greedy. I got, I tried to get an even better picture just because I was thinking, you know, there's a lot of wasted space over here that I don't need to look at. So I went back to the window, and you can't quite see, well, I think you can see it. I changed my X min to -1. I just deleted the 0 on the 10. And what that did is that cut off the wasted space, and now I've got this gorgeous picture of a parabola right here. And we're going to use the rest of tonight's video lesson talking about how to get these two x-intercepts right here and how to get this maximum vertex up there using the calculator. Okay, so here's our first live example. These are going to be word problems all through tonight and in class tomorrow, and they're really going to be a challenge for us. So I want you to promise me that you're going to hang in there and do the best you can, and if you keep plugging along, I guarantee that at some point we will eventually experience quite a bit of success. So hang in there, even if the first one seems a little overwhelming. So we described an object is fired upwards with an initial velocity of 112 feet per second. Its height in feet above the ground is a function of time in seconds since it was fired. And it's given by this equation. Now, you really don't have to worry about that 112 feet per second because it was built into the equation for you. This equation is going to be given to you. You don't have to create it yourself. And so the first question I want to tackle here is they asked me, at what height was the object fired? Well, here's the key. The moment the object was fired, the t value was 0. 0 seconds, because t is defined as this number of seconds since the object was fired. So I got t equals 0, so I'm going to substitute the 0. I'm going to evaluate h of 0 equals -16 times 0 squared plus 112 times 0. Now, you're more than welcome to plug that all in your calculator, or you can evaluate it by hand, and I just got 0 plus 0, which is 0. So I just decided the initial height was 0 feet the moment it was fired. All right, now we're ready for part B. They want to sketch a general curve of this equation. So I'm going to plug it into my y equals, and I'm going to generate a table of values, and hopefully and then we got to talk about where to put the y-axis and the x-axis in order to create the best looking picture, okay? So here's all my calculator work I tried to take some pictures of, and I don't want you to think that this is as easy as as it may look. This took me some time to create the right window. All I did is, I grabbed my calculator and I typed in the original function into y equals. And when I went zoom standard, I didn't see hardly a darn thing. I just saw a very, very steep line. And so I started playing with a few things. The first thing I settled on was a Y max of 200, okay? And then what I did is I changed my scale to 20s just so my x-axis was, so I could see the little dots on that y-axis, I guess. I did change my Y min to -50 so I could clearly see the x-axis. And then I trimmed down the left side of the graph. I got rid of some wasted space by making the x min -1. So I certainly encourage you to try to create that window yourself through trial and error. And then once you get to a certain point, you can use my numbers or something close to them. It doesn't have to be exactly the same, of course. And then went into my table of values, and I got a table that looked like this, and I could see that the vertex was somewhere between 3 and 4-ish, it looked like. That's where the numbers went from increasing down to decreasing, and so the vertex is somewhere between 3 and 4, and I got this beautiful picture like this. I'm going to try to replicate on this graph paper. Typically, when we do a real-life example, we limit ourselves to the first quadrant only, just because everything has positive values. And I'm going to count. I'm going to go 1, 2, 3, 4, 5, and 6. And then on the y-axis, I'm going to count by 20s. 20, 40, 60, 80, 100. I'll put a little 100 there to remind myself. 120, 140, 160, 180, and then 200. And that was 1, 2, 3, 4, 5, and 6. Okay, so then I'm just going to very carefully plot my points. 0, 0, 196. I'm going to plot that, the best I can. It's not going to be perfect. 2, 160 should throw me right around there. And then 192 is going to get me up around there. Then we just come back down. Let's see, at 6 it's about 96, and then on my table at 7 is when I hit the x-axis again. So my parabola is going to look a little something like this. Okay, and make sure I hit that point right there. Okay, so there's my parabola on my graph paper. I'm going to label the x-axis as time in seconds, okay, and the y-axis is height, and that's measured in feet, height measured in feet. All right, next thing they want me to do, now they said algebraically they wanted us to find the time that the rocket reaches its greatest height and then actual, like, the maximum height itself. We're going to do that graphically using our calculator. So ultimately, what I want to do is I want to find its highest point right here. And that's my question. How can I get that, rascal? And I'm going to show you, I'm going to walk you through how to do that on your calculator. Alright, here we go. I'm going to walk you through this as carefully as I possibly can, and I know the buttons can be a little overwhelming at times, so I'll try to, just very important to make sure you have your calculator with you and that you're doing these steps on your calculator as we go, so that when we get to class tomorrow, you can just hit the ground running and it'll be a real seamless transition. So as we try to find that highest point, the vertex, we're going to go to the second calc menu, which is you hit the second button and then hit this trace button, which is going to take you to what we call the calculate menu. And I want you to choose number 4 for maximum. All right. And the first thing it's going to do is it's going to ask you a question. It wants the left boundary. And I'm not sure where you should have like a flashing, blinky, what I call spider on your screen right now, somewhere on the curve. And depending on where that spider is, you may have to use your left or right arrow in the upper right hand corner of your calculator to move your spider. I want you to try to move it in this neighborhood right there. Get him so that he's just to the left of the actual vertex itself. And then I want you to hit enter. The moment you hit enter, it'll put like a little arrow up here, and it'll ask you a question number 2. It wants a right boundary point. So now we're going to use your right arrow to move that blinky spider over to the other side. Okay, get it in that neighborhood right here, and then hit enter. The moment you do that, it'll add a second arrow and a third question. It wants you to guess where the vertex is. And so I just use my left arrow to move that spider up at the top, the tip top, and I hit enter for a third time. So all in all, we hit enter 3 times. And now the word maximum should be printed on your screen with an x coordinate right here and a y coordinate. And I probably should have mentioned this at the beginning. Even though the equation was in terms of t, when we go to plug it into our calculator, we're going to use x's on the calculator screen. Now you'll notice there's a lot of 9s here. It's 3.499999 on my screen anyway. It might actually be 3.5 on yours, and that's what I'm going to round mine off to. So I'm going to say when t equals 3.5 seconds, that's when the object reaches its highest point. Its actual height is 196 feet. So all I did is that my x value was the time, my y value was the height, and we just described when and how high the highest point was. Now I know this is a very long problem, so hang in there. We're going to do one more part. We're going to do D, and this time, again, we're going to do it graphically, not algebraically. We're going to determine the time when the rocket reaches the ground. Okay, now when they say ground, I want you to think x-axis. When does this parabola hit the x-axis? In other words, what are its x-intercepts? And then we're going to label this on our graph. Well, I'm going to use the picture in front of us right now. This x-intercept right here is the one we're going after. So again, I'm going to create a series of pictures. I'm going to give you the play-by-play and walk you through the calculator steps. I think this one's slightly trickier than the maximum was, so let's be really careful. Okay, so here's how we're going to go find that x-intercept. We're going to go back to that calc menu. So we're going to hit second trace. Takes us back to the calc menu there. And we are going to choose number 2. That's 0. That's their word for x-intercept, like we said earlier tonight. Okay, now there's going to be 3 questions again, and the first thing they're going to ask you to do is for the left boundary. Now, one thing I want to caution you as you go through this, do not use the up or down arrow. I'm always tempted to do that. We're strictly only going to use the left and right arrows. So depending on where your little blinky guy spider is, I need you to get him in that vicinity right there. So either use your left or right arrow to get him in this neighborhood, and then I want you to hit enter. And the moment you hit enter, they'll throw a little arrow up in that corner. And I need you to hit the right arrow a few times. And what it's going to do is it's going to drop it down along the curve. And this one's hard to see. My spider's right here, okay? And that's when I want you, once you get it down below the x-axis, it's just slightly to the right of the x-intercept. We're going to hit enter a second time. As soon as you do that, it'll throw the second arrow on your screen. And it wants the third question, which is to guess. We're going to hit the left arrow like maybe twice or so to get that spider, you know, the best you can. It doesn't have to be super precise. Get it as close as you can to the actual intercept. Hit enter for the third time. The moment you do that, presto, the calculator is going to say there's a 0 at x equals 7, and that's right sitting right there. So we're going to say it takes t equals 7 seconds for this object to come back down and hit the ground, and of course its height would be 0 feet because it's actually hitting the ground. That's why you see the 0 here. So I hope you felt comfortable with those calculator steps. I hope I showed enough work here on my screen. Let's go practice a little bit more calculator. Okay, example number 2, we're going to talk about a skateboard half-pipe ramp has the shape in the form of a parabola whose equation is, check this out, y equals 0.06x squared minus 1.2x plus 7. X represents the horizontal distance across the 20-foot wide half-pipe, and y represents the ramp's height above the ground in feet. So again, the x-axis here is the ground itself. With the help of your calculator, sketch the graph of this half pipe below, label its height at its endpoints and its minimum point. Alright, so I went to y equals, and you know, probably as I was reading this you were already there, and you just typed in 0.06x squared minus 1.2x plus 7. And as a rule of thumb, I always go to zoom and I hit 6 and I start standard. And the problem is I was staring at this picture right here and I'm only seeing about half of the half pipe. So I want to extend it a little bit. So what I did is I went back and I hit the window button at the top, and I changed my X max to 25. Now the width was 20, and typically I want to go like a little beyond that so I can see the entire picture. And then I changed my X scale to 5 units, but that's optional. And here's the picture I came up with. And it looks a lot better than the first one did. And so again, my X max right here is my 25. And I believe my Y min is still negative 10. My Y max is positive 10, and my X min is negative 10 still. So much better picture. I could have trimmed it off. I could have tweaked some other things, but anyway, so we're ready to graph it. We need to get this on graph paper. And so I'm going to set up my axes again. I'm going to put my Y axis right on the left edge. I need to fatten up my pen here a little bit, I think. How's this look? Whoop. Okay, there we go, a little fatter. Alright, and there's my x-axis right there. I need to go by 20s, so maybe, let's see, 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Now the heights, what I'm going to do is I'm going to go to the table, and I scrolled up and down the table, and at x equals 0, the height was 7. And then it just goes down from there. So I'm just going to go 1, 2, 3, 4, 5, 6, and 7 right there. Show my 5, show my 1. That'll get the job done. And I'm just going to start plotting points to see what I come up with. And then we'll answer those 2 little questions they had at the end. So I plotted every other point. I plotted the 0, the 2, 4, 6, 8, etc., etc. And I ended up with this nice parabola right here. They wanted me to label the heights at the endpoints. What I did is I went to my table, and the table said that when x was 0, the height was 7. And they also said when x was 20, I just had to scroll down a little bit, that the height was also 7. And then the minimum point was right here at 10. And I ended up with 10, 1 for a height. If it's not a friendly number, we got lucky this time, it was a friendly number, 10, 1. If it wasn't a friendly number, we could have gone to our second calc menu and done the minimum feature. We would have had to create a left bound and a right bound, and then we would have guessed and got 10, 1. Alright, really good job hanging in there so far. I know this is a long video and you're doing a good job and you're working hard with your calculator. So I just want to finish up with one more problem here to really see if we're ready to tackle what we're going to see tomorrow. I've given you a very strange looking function here. And I want you to know that on your calculator, we're going to type an X on our calculator to represent the temperature. And of course, the Y's on the calculator represent the percentage of kernels that got popped. And so what we're going to do is we're going to go to y equals and we're going to type in this function just the way you see it. Make sure we've got a negative in front of the 1 over 250 x squared plus 2.8x minus 394. This is a very tough window, and I'd encourage you to try to experiment with this window yourself. Try to make the x max big, try to make the y max big enough so that you can start to see the graph, because when you go zoom standard you don't see a darn thing. And so experiment with that, and then come on back and I'll show you what my window was and what my graph turned out to be, okay? Okay, so here's what I got my screen to look like, and yours hopefully looks somewhat close depending on what your values were. Now as far as this window goes, and this is how I may show in class tomorrow, or I will show it, the first number is my x min, the second number is my x max always, and then that third number is my x scale. And yours don't have to be exactly the same, but if you want to see the same picture I have, then I would suggest you can go to your window and adjust those. And then I've got my y min and my y max and my y scale, what I counted by. And if you set those numbers to be the same, you'll see exactly the same picture that I've created here, where you can see the entire parabola very nicely. So what they want us to do is to find the highest percentage of kernels that get popped. So in other words, they want us to go find the maximum. So I'm going to go to my second calc menu. I'm going to choose choice number 4, which is max. I want you to try that on your own. Try to create the left edge, the right edge, and then find guess at the center and see what you get. So here's my picture, and by the time you hit enter 3 times, right? So you did like a left edge somewhere around, let's see, somewhere around here, and then you did a right edge here, and then you guessed up here, and after you hit enter that 3rd time, you see the word maximum in the lower left-hand corner, and 350 is your x. Now remember, x represents your temperature, so we would say when the temperature is 350 degrees, you're going to create, you're going to get your highest percentage of kernels popped. In fact, 96% of your kernels are going to pop. That's a great percentage. Always drives me nuts when take a bag out of the microwave and the kernels aren't popped all the way. All right, one last little question here. We want to go find the zeros of this graph, and then I'll let you go for the night. So the zeros, again, are the x-intercepts. In other words, what I want to go find now are these little rascals here. And what I'm going to do is I'm going to do the one on the left with you, and I'm going to walk you through it, and then I'm going to turn you loose. I'm going to let you do the one on the right and bring that into class tomorrow for our notebook grade, okay? So here's how we're going to do it. So the key is we have to go get those 2 roots individually, one at a time. I went back to the second calc menu, and I chose choice number 2, which was zeros. And the first thing I did is they're asking me to find the left edge, and so I moved my spider down in this neighborhood right here. So you use your left and right arrows depending on where you started. You're probably going to have to use your left arrow. Do not, I repeat, do not use your up and down arrows, just your left and right arrows. And I hit enter right there, and as soon as I hit enter, it threw an arrow on the screen. And then I moved they wanted the right bound, so I started hitting my right arrow several times until this little spider got up there. And once he gets in this neighborhood right here, I hit enter. And then it wanted me to guess, and I just used the left arrow a couple of times until he got in this neighborhood, and I hit enter a 3rd time. As soon as I hit enter that 3rd time, it showed up with a 0, and it said the root, or that x-intercept, was about 195. So we could say that when the temperature equals when the temperature equaled 195, whoa, my pen changed on me. All right, 195, that 0% of the kernels popped. All right, so what are we going to do now? Before I see you in class tomorrow, I'm going to have you find this x-intercept all by yourself. Now your left edge is going to be right here, your right edge is going to be in this neighborhood, and then you're going to guess somewhere around here, and make sure you hit enter a 3rd time so that you see the word 0 on your screen, and I want to know what temperature that is right there. So good luck, and I'll see you tomorrow.